Okay, hi everyone. Today we are going to go over inequalities again. So, graphing inequalities. And this is our main goal. Our main goal is to end up graphing inequalities today, specifically in two variables. So, but before we go there, we want to talk about what's the point of inequalities again? What's the point of inequalities? And let's take this on our 1D plane, right? Our 1D plane, what we first talked about. If I say, if a friend asks you, hey, when will you be home today? When will you be home today? And that's a semi-math question, right? When will you be home today? And you would say, for instance, I'll be home all day long. It's lockdown. I'm just kidding. So you would say, I'll be home after 3. So t is greater than 3. Right? You could say, I will be home at 3 and onward. 3 and onward. And the idea of these two graphs here, they look very similar, but there's a slight difference in them. So here's 3, and here's 3, and we would say a hollow because you're going to be there after 3, right? I didn't say I'll be there at 3. If they call you at 3, I'm not home yet. But if I was going to be home at 3 and after, see, I'm including the 3. And we had that small notation. Math people are super efficient at their notation. The goal is to say, hey, equal means included, not equal means don't include it, right? Don't include it and include it. And it's important. Am I going to include that number or not? So, a problem that I came up with when we had children is that children eat free, or children go to Disneyland, right? Children go to Disneyland free to the age of 2. And I was thinking, what if they turn just 3? What if it's their 3rd birthday? Would that count? And the answer is nope. They had to be less than 2, or less than 3, less than 3. So it's not less than 2, it's less than 3, because any value up to 3 would be good. So these numbers these inequalities are useful in life. They're helpful. They describe certain situations specifically. So let's move on. Now, we had a couple of rules that we had for inequalities. If I was solving for it, if I say 2x, sorry, let's use this. 2 minus 3x is less than, let's use the number, let's say 7 here, okay? Not 7, let's use 11, sorry, 11, okay? How do we solve this number? Solve for x. If I'm solving for x, we would have to get rid of 2 and 3. You guys go with that? Get rid of 2 and 3. I will get rid of 2. Opposite operation of plus 2 is minus 2 to both sides. Negative 3x less than 9, if you guys remember that. And then my next move is I would divide both sides by negative 3. Now when I divide by negative, careful, if I move a negative from one side to the other using multiplication or division, we have two options, multiplication or division, you had to remember to, okay, remember how to flip the inequality. Okay, flip the inequality. So when I do this, x and negative 3, 9 divided by negative 3 is negative 3. And we had to flip the inequality. You had to flip that. Okay, so a couple of rules that we need to know before we engage in today's lesson, just as a backup, if you don't remember these, okay? All right, 2 things. One is how to graph them in general, the solid and hollow. And the second one was remembering to flip the inequality. Now, the whole idea again of inequalities is to say that there are more than one answer that would have been correct, more than one possibility. And when we graph a line, we're not saying that. In essence, we are, but we're not saying that. We're saying, if I say y is equal to 2 over 3x plus 1, let's go ahead and graph that. To remind yourself, what do I graph first? The 1 or the 2/3. The 1 is the y-intercept. The 2/3 is the slope. So if I'm graphing this, the y-intercept is in the y direction. That's at 1. Put a dot. And then the slope is up 1, 2, and the rise is 2, and the run is 1, 2, 3. So this is how we normally would graph a line in slope-intercept form. You would look at the y-intercepts, and then you would follow the slope to get to your next point. So all the answers on this line are answers to this equation. Now, let me verify that just to follow it. If we said this was 0, 1, that's my first point. If we rise 2, the next point would be 3, right? Because 1 becomes 3 by rising by 2. And if I run 1, 2, 3, 0 becomes 3. So the question is, 3, 3, is that a point that would make this statement true? Is this still a point on this line? So let's go ahead and try it. If I said x was 3 and y was 3, 3 is equal to 2 over 3 times 3 plus 1, where this is x and y, okay? My x was 3 and my y is 3. Would this still be a true statement? 2 times 3 is 6. 6 divided by 3 is 2, and 2 plus 1 is 3. This is a true statement. Yes. It worked. So 3, 3 was a point that works. That makes this a true statement. Let's try it again. If I climb, let's find what this point would be. If I climb 2 spaces up and I run 1, 2, 3, what would this point be? Well, if I rise 3, 2 spaces up would give me 3 plus 2 is 5 now. Okay. So 1, 2, 3, 4, 5. That kind of looks like 5, yeah? And then my x, if I say 3, move over 3 spaces, would give me 6. Would this also be a valid point? Let's check it. 5 is equal to 2 over 3, 6 plus 1. How did I get these numbers? I said this is my x and this is my y, and we're checking if this would be true for this equation, for this line equation. Would this still be a true value? Well, 6 times 2 is 12, and 12 divided by 3 is 4. 5 is equal to 4 plus 1. Hey, this 2, 4 plus 1 is 5. This is another true statement. That's a number that works perfectly. Now, if I want to pick any of the decimals in between, any of the half points, yes, those will always work. Any value on that line would be true. It's almost like a bus route. You guys ever hop on a bus? I've been on buses, right? The bus stops at a lot of different points along the way, and all these are on the same bus route. Okay? And not all of them are places where you want to get off, right? Okay, so what if I change this into an inequality now? Let's change this. If I say y is greater than or equal to 2/3 x plus 1. So if you notice, the main difference here now is that I've changed the equal sign not to a must be equal to, but a inequality that says, hey, you could be equal or greater. Equal or greater. Now, how do I graph this new type of equation? And actually, it's the same thing like we did before. We're going to graph the y-intercept, which is at 1. And we're going to graph the slope, which is 2 over 3. So rise 2, 1, 2, and run 1, 2, 3. So none of the steps are any different so far. We still draw our 2 points to describe our line. And then, as mentioned before with the equal sign, we're going to draw, we have 2 options here. Now I'm going to draw this on the side here. If it's greater than or equal or greater than by itself, the graphs actually look different. So I'm going to draw this real quickly on the side for you. If it's greater than or equal, it's going to be a solid line. But if it's just greater than, it's going to be a dotted line. So please notice it's going to be solid or dotted. And the dotted line is almost like me drawing a bunch of hollow holes instead of drawing a line. Okay? I'm just using dashes because it takes me less time to draw dashes than a bunch of hollow holes. Okay? So since this is an equal sign, this is going to be a solid line. solid line. So I'm going to just draw my line. Now, what does y greater than the line means? Okay. Have you guys ever, if you guys have brothers and sisters or siblings, have you guys ever played the game, not really a game, where you said, this is my half of the room, and that's your half of the room? So anything on my half of the room is mine, anything on your half of the room is yours. And that's actually what we're doing now. We're saying y is on my side of the room. So anytime your y is greater than, we are going to shade above the line. Why do we shade above the line? Because all the y values above the line, are okay. They're good with me. The example is a dumb example, but let's say, girls, you're looking for someone to date. And I get it. You're looking for personality. Sure. Personality. Okay. But imagine if someone, like, you have criterias, right? You have standards. So you're looking, let's say, for someone who's rich and handsome, right? Rich and handsome. Do you have a level of handsomeness? What if he's super, super handsome? Are you going to say no? What if he's extremely handsome? Are you going to say no? The point is that it's a range of values. What if he's a little bit rich? Okay, that's fine, as long as he's rich, right? What if he's super rich? That's good. What if he's super, super, super rich? What if he's a billionaire? Yeah. Okay. So in life, like we mentioned before, it's not just one answer. Lines are great. These are just one answer. But inequality says there are a whole range of answers. All these answers are cool with me. He could be a little bit rich and a little bit tall. Oh, a little bit rich and a little bit handsome. He could be really rich and really handsome. He could be a little bit rich and a little bit handsome. You know what? All I care is he's above that line. Kind of a dumb analogy, right? But that's how we buy things. For instance, when you guys are buying toys, let's say your parents are buying you a new iPhone. You say, I just want the iPhone 12. But is it just iPhone 12, or aren't there different versions of the iPhone 12 that you'd be just as happy with? But you don't want no iPhone 11, just anything above a 12. Okay? So it's a range of values. So let's go ahead and graph this again, but I'm going to change this. Y is greater than, just greater than, not equal to. So this is a dotted line now. So we're going to graph the same graph. The y-intercept is 1. Here's 1. And the slope is rise 2 and run 1, 2, 3. And instead now, we're going to do a dotted line. So please take a look. Take note that this is looking like the same line as before. Look, they're parallel. They look exactly the same thing. Except because you're not allowed to touch the line, it is now dotted. The example is like in many sports. Are you allowed to dribble a basketball on the line? No, it's out. You can't touch the line at all. Your feet can't even touch the line. So you're not allowed to touch it. Don't touch it. Okay? It's not included. Okay, is this included with the menu? Nope, that's extra. Do you want soup or salad? I want both. That's extra. That's not included. You get one. So dotted. Now the next thing is, as we mentioned before, y is greater than. So pick any point. Let's say I pick this point here. Everyone see this point here? Y is greater. That means we're shading up. Pick any point you want. Y is greater. Put your pencil on your graph. Y is greater. That means we're going up. So we are shading on top again because y is greater. And this goes all the way. Make sure you shade all the way across your picture. Don't skimp on me. This covers the whole breadth of it. Keeps on going. Okay? Anything on top of the graph is valid. So let me use Desmos as just an example that you guys can see. So I'm going to write y is equal to, we'll start off with equal, 2 over 3 x plus 1. Okay, and this is our line. This looks very similar like our first line that we drew. Now I'm going to change the equal sign. And instead of using equal sign, I'm going to use an inequality. Let's see if I can find inequalities here. Oh, no, inequalities are written a little differently here. I forgot. So it's going to be y. I need my keyboard. Nope. So y is, oh, here it is, greater than or equal to. If you notice, it's shaded because all this part in red, all this, I think this is red, I'm going to colorblind here. All these values, all this area here in red, all this area here in red are possible answers. You can almost say this is the playground. You can play in any of these fields here. If x is 2, as long as y is bigger than the line, you're great. If x is 4, as long as you're bigger than that line, you're good. As long as if x is 0, as long as you're bigger than 1, you are totally cool. Because it's not just one answer anymore, it's a range of answers. So we do that by drawing a shaded line. Now if you guys take a look here, we said this was greater than or equal to, and if you look at the line, let me make this a little thicker. The line is solid. I'm going to change this quickly so you guys can see. Solid versus dotted. Whoops, lost it. Versus, you can notice that is now a dotted line. So that's the big deal. If you're drawing solid or drawing dotted, you want to make sure that it's very noticeable for the person reading the test. And there is a big difference. Dotted means do not touch the line. These are not included. These are not part of the graph. We're just using them as an invisible border. So we know above this, we're cool, but don't be sitting on that line. Do you notice the difference? One is dotted and one is solid. So I'm going to draw them. I'm going to draw one next to each other, slightly off skew. If I use y is greater than equal to 2 over 3 x plus 0. See, just so you guys can see that. One is dotted and one is solid. So there is a difference in how we're looking at this. Okay, so let's write out my third version. Y is greater than or equal to 2 over 3 x plus 1. Actually, you know what? Let me change this inequality since we have a little bit of time here. Let's change this and we'll make it a less than or equal to. So this guy is solid. Okay, this guy's solid, but less than. How do you know it's less than or greater than? Remember in English we read from left to right. So y is smaller than the line. Because if you look, remember we mentioned this little tiny little bit versus this huge side here. Y is on the small side of things. So y is less than the large gigantic line. You guys as freshmen are shorter than the gigantic seniors. And unfortunately you would see that as when we start school again. And those seniors will be even taller than they should have been in the fall. Okay, so here we go. So we start at 1 because that's my b value. My slope is rise 1, 2, run 1, 2, 3. This hasn't changed. Is this a solid or dotted line? Because of the equal sign, that means you are allowed to be on the line. This is included. Now, from here, we say y is less than the line. So pick any point. Everyone put your pencil on your graph right now. If you guys are done drawing it, put your pencil on the graph. And which way would less than be? Y is less than. All the y values, see, well, these are y's, right? Which way would y is less than? Would you go up or go down? Would you go up or go down? You would go down, right? So we're going to be less. All this part is less than the line. Does it matter which way you draw the lines? Can you draw them horizontally? Can you draw them diagonally? Can you draw them vertically? Nope, it doesn't matter at all. Okay, it's just different ways for, I don't know. I mean, it doesn't matter which way you draw them. You can even use a highlighter if you want, but highlighters kind of soak through your paper. Do you have to draw so many lines? No. If you just draw like one every other, well, we'll make it a little more even. Let me fix that. If you just do this, let me show you. Bam, 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 bam. This would be the same meaning, right? Looking at this, you can tell I'm shading below the line. Some of you guys are a little OCD, and you guys will try to get every nook and cranny, every nook and cranny. You don't need to do this. You don't. So don't. Okay? I think it looks a little neater this way. Now, here's a follow-up question. Follow-up question is this. is point 0 comma negative 3 valid? Would point 0 negative 3 be okay looking at this equation here? Would that be a true statement? Would that be a true statement? Let's try it. If I plug it in, negative 3 is less than or equal to 2 over 3 times 0 plus 1. Would this still be a true statement? Well, 2 over 3 times 0 is 0. Is negative 3 less than or equal to 1? Is this a true statement? Is negative 3 less than or equal to 1? Yeah, negative 3 is less than 1, right? This is a true statement. Yes, 0 comma 3 is valid. It is a good point. Now, we could plug it in and that's great. And we have to be able to practice it without drawing the equation. But I want you guys to look at the graph right here. If you look at the graph, 0, negative 3, isn't that right here? And isn't it in the mist? Isn't it buried deep within our region that we say it's okay? Yeah. What happens is that it's no longer just points on the line that are true. It is anything in this shaded region. So that also means if I pick a point, let's pick something like, let's say pick like 2, 0. See the 2 zeros here? 2, 0. Do you think that's gonna work? Is this gonna be a true statement? If I pick let's say 5, negative 1, 5, negative 1, would this be a true statement? If they are in the shaded region, this will become a true statement. And let me go ahead and just try that, even though it looks a little ugly. 0 is less than or equal to 2 over 3 times 2 plus 1. Would that be, so this is going to be 2 is 4 over 3. 4 over 3 plus 1, I'm going to change it to 3 over 3. 7 over 3. Is 0 less than 7 over 3? Yeah, 0 is smaller than any positive number. This is true. And as long as the statement is true at the end, it's a point on that graph that works. 2, 0 would work. 5, negative 1 would work. Any value underneath the line would work. So on your IXL today, you guys are going to do 3 IXLs to a SMART score of 70. Again, 3 IXLs to a SMART score of 70. When you're doing these 3 IXLs to a SMART score of 70, the first one's going to say, hey, is this a true point? The second will be solve for y, and we're going to work on that right now. And then the last one is just to graph these two, to graph the line, would you shade up or shade below? So let's do that last point. What if the line is not written in an easy way? What if I write 3x plus 2y is less than 4? Let's say this is our starting, and they want us to change this into slope-intercept form. Y is equal to, or y is less than, or y is greater than, something like that. Okay, solve for y. Solve for y. Okay, we're going to take our cues from all the work we've been doing. We're going to solve for y. To solve for y, we need to get rid of our 3x and our 2 to get y alone. Since 3x is farthest away, we're going to ask 3x to leave, minus 3x to both sides. We're left with 2y is less than negative 3x plus 4. My first question is this, just to make sure we're all on point here. Because I subtracted the negative over, does it mean I flipped an inequality? Do we flip an inequality just because we subtract or add? No, we only flip when we multiply or divide across by a negative. Only flip if we divide or multiply across by a negative. So no flipping. Our next move is let's go ahead and divide this by 2 to get rid of that 2. Divide everyone by 2. Y is less than negative 3 over 2x plus 2. And this is the goal, for you guys to be able to solve for y. It's something that we did before. This is us changing something from standard form into slope-intercept form. And this was on our last test. Right. Let's do one more. If I give you 5x minus 3y y less than equal to, let's say, 15. Okay, so this one we're going to have a issue. No, I'm going to erase the equal sign. It's not going to matter to us. Let's go ahead and talk about what we're going to get rid of first. We're going to get rid of the 5x first, and then we're going to get rid of the 3. Let's go ahead and do that. Minus 5x to both sides. Again, when I minus the 5x, do we have to flip the inequality? Do we have to flip it? Nope. We only do it for multiplication and division. 5x and 5 are not like terms. That's why I wrote them next to each other. Separately. Our next move, we want to get rid of that negative 3. So do not think you're going to add 3 to this. The opposite of multiply is to divide. That's our opposite operation. We're going to divide both sides by a negative 3. And I'm going to divide them all by negative 3. And that's a skill that we've been practicing. So y, 3's divide out, because leaving just y alone. And we're going to end up with negative is a positive 5 over 3 x. And a positive divided by negative is a negative 5. So be careful there. And the big deal here is, since I divided by a negative, we have to flip the inequality. Flip the inequality. Oh, whoops. I don't know why I did this. There's no equal sign. Remember, I erased the equal sign? For some reason, I like writing equal sign there. This is a force of habit. Gotta be careful. Okay, so these skills are something that we worked on before. This actually is not new. Only thing is that we're combining two skills. Solving for y, and don't forget to flip the inequality when you have to. Okay. So your IXL work, the question is, does this point satisfy the inequality? Okay, and they gave you 210. So what you're going to do is you're going to just plug in the numbers and see if that's still a true statement. Okay, is that a true statement still? So let's go ahead and plug in our 10 and our 2. So x and y, please make sure you don't get that mixed up. X and y is 10, x is 2. 10 is greater than 2 plus 1. Is this a true statement? Is 10 greater than 3? Yeah, that's a valid point. So what happens is, if we graph this, y-intercept is 1 and the slope is 1, rise 1 over 1. This is my line. Sorry, it's actually dotted, right? First mistake is dotted. Is point 2, 10 inside my shaded region? Yeah, it is. So instead of having to graph everything, I just need to plug in the numbers to make sure this is a valid point. Yes, it is valid. Great. Come on. And then we're going to say, yes, it's valid. Done. Okay. Is this a true statement? Is 510 going to be a true statement here? So we're going to plug in 5 and 10. X is 5, y is 10. Again, this is all practice. Right? Don't take this for granted. That's 5 times 12 is 60. Plus 11 times 10 is 110. Is this greater or equal to 1? Yeah, that 60 plus 110 looks like that's 170. And 170 is greater than or equal to 1. This is true. The point in this is to realize that there's not just one answer, there's a lot of different answers, a whole range of answers. Okay, 170 is greater than 1. This is true. Is it always going to be true if I just guess true? Oh man, me guessing is going to get me in trouble. Okay, so if I actually spent a couple of seconds to do this problem, we could have checked. If I plug in x and y is 10, x is 1. Is 10 greater than 6 plus 4? Is 10 greater than 10? Is that a true statement? Is 10 greater than 10? 10 is equal to 10, but it is not greater than 10. It's like your little brother telling you, or twins. I'm a twin, right? Imagine if my twin said, I'm older than you. No, you're not. We're twins. So don't even bother trying. Okay. So nope, this is not a true statement. So that's why this was no. Okay. Besides that, that's pretty much it. I think this was the only thing I wanted to go over. And that's it.